Nice to be here. Thank you for coming to this talk. I hope you will all learn something new today. We're going to talk about making LLMs reliable, and I'm going to show a practical framework for production. But before we start, just curious, who here is building LLM-based products? 80% of people, I think. And who is building chatbots and agents? Oh, also a lot of people. Okay, interesting. And whom of you written Python custom implementation for evaluating LLMs? Okay, maybe like half. And anyone has a favorite existing LLM Eval library that you are using? Okay, that's significantly less people. Okay, cool. My name is Lena Shakurova. I'm an AI advisor and founder of ParseLabs. It's a conversational AI agency. And Chatbotly, it's a no-code platform for building AI agents. Since 2018, I've worked on more than 100 different conversational AI automation projects. And in the past, I studied AI. I did research masters, and I had a long career working in different roles in this space, working as an NLP research engineer, full stack Python developer, and then freelancer, and now owning the agency. And apart from that, I'm also a public speaker, and I'm sharing a lot of things online on my YouTube channel, newsletter, and talking about practical human-centered AI. Why this topic today? A while ago, a few weeks ago, I posted a resource on LinkedIn where I collected 61 different LLM eval tools, and I was sharing it with people. And this one got kind of viral, and 40,000 people saw it. I got a lot of likes, and I started talking to a lot of people about the topic of LLM evals. And the way it would also work is that to get the access to the resource, you will answer this question, like which LLM eval tools you tried. And I got around 200 submissions. And I found it very interesting. Most of the people who submitted, they are not using any evals at all, and only a small percentage, around 30 people who I talked with, do. And I also discovered that most of the people are still doing vibe evaluation, so just checking if they like the output and then they do something. Then a bit less people are doing manual evaluation, which means that maybe they have a test set, but then they manually are still checking the things. Then still quite a big amount of people are using custom Python code, so that by far was the favorite thing. If people don't like using existing eval libraries, I'm still trying to understand why. And yeah, just a few people are using eval libraries. So I thought that was interesting, and my main conclusion was that the topic is really popular. Everyone wants to figure out how to evaluate LLMs. We still don't have a proper framework for that. And we are still pretty much figuring things out. So this is why the talk. If you are curious to see the different other eval tools, then you can scan the QR code and get it there. I'll wait a second. And today we're going to talk about many things. First, we're going to cover why you shouldn't launch without evals, what are the different kind of risks. Then we're going to cover how to build a good test set, what does that mean, different practical tips for doing that. Then different LLM eval metrics so that you can choose the one that works for your use case, because in this space there are a lot of different use cases. And then we're going to go through the LLM framework, which consists of 3 stages: experiment, monitor, and improve. And I hope that by the end of this talk you'll get some knowledge and feel more confident release into production after you set up the proper LLM eval system. Okay, so why shouldn't we launch without evals? The core problem, and I'm sure you all know, is that LLMs are non-deterministic and unpredictable. And that means that with the same output, we're going to get different, with the same input, we're going to get different outputs. So every time we send the exact same thing, you're going to get a bit of a different thing out. And that's a problem, and that comes with many risks. Some of them are written here. So the risk of hallucination is quite common, inconsistent outputs that lead to poor business outcome, harmful outputs, jailbreaks, data and PI leaks, and we're going to go through them quickly one by one. So with hallucinations, it's when LLM generates confidently information that it's false. Why is it bad? Well, for users, they waste time chasing solutions that are incorrect. That's pretty bad. And they can be acting on bad, wrongful information. which can lead to wrong outcomes. And when it's in healthcare or a legal domain, that's pretty bad as well. And for business, it can ruin your business credibility. And this thing is very common. It's one of the most common risks of working with LLMs. Then inconsistent output also basically comes out of the box when you work with LLMs, and it's also pretty likely for the users if the output every time is different, even if you send the same thing, and then they get inconsistent user experience, and that's pretty bad. They get confused and they lose trust in the system. And they waste a lot of time. And for business, that leads to user being frustrated with the app, because every time you're trying to do something with it, you get a different result. You get lower user satisfaction, and the brand credibility also suffers. Then harmful outputs that when LLM reinforces biases and stereotypes. So for users, that means that they might feel insulted and validated when they get inappropriate response from the LLM. And that can also lead to real world damage if it is related to misinformation about health, law, finance, and things like that. And for businesses, basically same risks as always: broken trust, brand damage, and legal lawsuits. And this one is quite possible. However, I think most of the LLM providers, if you are using the ones out of the box, they are already doing something around that. So for practitioners, unless you are using open source LLMs, that's less likely, but when that does happen, it's a very high impact. Jailbreaks, bad actors making LLMs bypass different safeguards. So that's when attackers are doing prompt injections and they can maybe get dangerous instructions from LLM, like how to build a weapon, or they leak some data from the company. So for the company, it's also pretty bad. The harmful code can be executed, the proprietary data can be leaked, and that all leads to legal liability and reputational damage, so also bad stuff. This is less frequent, I think, because there are less bad actors using your LLMs, but when that does happen, it's also very high impact. And the last one is the data and PII leaks. Basically similar. Private conversations leaking, sensitive info like about your health or sexual orientation also being made public. That can have a long-lasting emotional harm on your users. And for companies, it's also lost trust and brand damage. Also, I think this one is less frequent but high impact. So yeah, this is all pretty bad stuff. And the core problem is that LLMs are, the core problem is that non-reproducible outputs mean that your product is unreliable. And in high-risk domains, we just cannot afford that. Working most of the time is just not an option. So as AI developers, I believe that we are the ones that are responsible for setting it up in an ethical and a safe way by design from the beginning, because we are the ones who actually understand how those things work. Your project manager, product manager, and other people understand less about those risks. So we have to take the responsibility for that. Let's do that. So what are we going to do? We're going to start with making a good test set. And a good test set is the test set that's designed for representing your use case and it covers real-world examples as good as possible. And the good test set answers two questions. One is, what is important to measure for my use case? That can be, for example, your domain-specific example, specific for your specific industry. And you will see a lot of pet examples here. That's because I work with a property management company, and everyone is asking about, can I bring my cat or dog, or what are the breed restrictions? So, for example, what's your pet policy? That's important for my domain. Or like edge cases like transfer to human. The second question that's important is what does good in my domain mean? So how are we going to evaluate that? And there are two main things how we can define what good is. One is by providing reference responses of what good is, like we allow cats and dogs in our community, or defining custom specific criteria. Like for my use case, it's important that my AI assistant for this property management company gives short answers and is always polite and things like that. Remember, we discussed all those risks. Well, a good data set needs to cover all of them. So hallucinations, inconsistent outputs, harmful output, jailbreaks, and data and PII leaks. And I would say that hallucinations and inconsistent output is 100% needs to be the first thing that your test set covers. And other things, it really depends on what kind of LLM you are using. If you're using the one out of the box or the open source, then you might want to set up more safety mechanisms. And to cover all those risks, you need to define happy paths, so your use case specific examples, edge cases like out-of-domain questions when the user asks something that's not relevant to your application at all, when the user switches to a different language, when the user is being rude, so things like that. And then test set needs to include sensitive topics, so when people start to talk about mental health, finance, etc., and jailbreaking attempts. And this is the idea that I suggest how to build that. You first imagine what kind of cases that your user might have. You need to start somewhere. Then you try to test, and as soon as possible, you look into your logs, and then you get those examples for the test cases from your production logs. So you are not using imaginary examples in your test case. And then you keep repeating, so creating a good test set is a long process, and it will be evolving as your application is evolving, as you are getting more users and as you are covering more use cases. I also have a few tips on how you can build a good data set. Well, the first thing I would start with is talk with your subject matter experts and ask them to help you come up with this test set, describe the use cases that they personally often see, and label them. So provide the reference answers, or the evaluation questions also comes from them. Then take examples from company guidelines, SOPs, and onboarding documents, and that maybe does not apply to every one of you because we all are building different applications. But for example, if you're building AI agent for HR, probably there is some HR onboarding document where they say what a good HR needs to be doing, and they literally have this as a list. Or if you're building an AI agent for customer support or sales, they also have SOPs of how the conversation for the sales agent needs to look like. So a lot of documents were already created for humans, so reuse them and build your test set based on that. And as I mentioned, also always take examples from production logs, not made up. A few more things. You can generate synthetic test data. I personally, for our projects, rarely use that, but it's one of the options that's worth mentioning. I think it's good if you need to test something at scale, and with synthetic data, you can start with defining things manually, checking it with your SMEs, and then generating paraphrasing changes and tone shifts, and then you can test things at scale. But here it's important to remember that synthetic data is not real-world generalization, so I would never start with synthetic data as a first thing, or at least in use cases that I've been working with. What else? There are also different prompt injection datasets available, so if you want to cover this jailbreaking risk, this one is from Hugging Face, so you can use examples from there. Then there are also adversarial data sets. So this one is from Harm Bench. Also has a lot of different examples from bad actors. And evidently, who were speaking yesterday, they also have this huge table with other data sets on this topic, so you can get some inspiration there. Okay, so now to metrics. When we are working with LLMs, same input means different output, and we want some sort of score that will tell us that when we are improving our prompt, that we are doing somehow better. This is what we are used to when we are working with machine learning models, and with LLMs, it's a little bit harder to know if you are progressing. Remember the core problem, so LLMs are non-deterministic, the same input means different output, but that also means that different output means that different output can be good. So how do we evaluate things when multiple things can be correct, and there are endless things that can actually be correct? I separated the metrics for LLMs into 4 different categories. So the first is the classic one that you used before, is just pattern match, regex, syntax validation. So things like if it starts with this, or if the sentence contains this. So you can still use those for some of your use cases. Statistical, so F1, score, accuracy, precision, recall, they all work for the LLM classification tasks just as well. And then there's Blue Rouge, also all metrics that can compare the similarity between the reference and the generated output. Then there are ML-based metrics like semantic similarity, word score, and sentiment, and there's something called LLM judge. I think the ones on the left you probably are familiar with. I'll just explain what LLM judge is. But before that, who knows what LLM judge is? Okay, not everyone, but a lot of people. So just quickly for those who don't know, LLM judge is basically when you are using another LLM to evaluate the output of your LLM and to assess a certain quality of your generated text. So on the image, you can see that you can paste into your LLM evaluator things like input, what LLM output was, the retrieval context from a RAG and things like that. And then you'll have an LLM judge score. So this is your LLM evaluation prompt, which will take all those things and will evaluate it according to a certain criteria. And then it will tell if it passed or not. For example, was this text polite, yes or no? And then you define what polite is, and then you get a score. And this LLM judge is really good because when we are working with LLMs and with this many outputs that can all be correct, custom criteria is works better than generic metrics. And we want to measure what's important for us, and with LLM judge, you can literally measure everything. You just define what good is. And of course, it comes with its own drawbacks. We'll talk about it a bit later. But first, few examples. You can use LLM judge on a dataset with no reference. So let's see. The green thing is the test set. So you have a question, for example, what are the top attractions in Paris? And then evaluation question. Is the answer generated by LLM friendly? And then you, of course, need to define what friendly is. And then we get LLM output. And we have this LLM judge on top, which takes the evaluation question and it checks it against the LLM output. And it says, was it friendly or not? Okay, correct. And gives some explanation. Yes, it uses polite tone and positive language and things like that. And here, there's this thing says one eval question for all questions, and by that I mean that maybe for all of the sentences that your LLM generates, it always needs to be friendly. So this is like a stable property across your whole data set. Then you define this evaluation question once, and you apply it to all your questions. But you can also do it a bit differently, and you can create such a test set where you write different evaluation questions for different user questions. For example, here it might look like this. What are the top attractions in Paris? And we can decide that, okay, for any kind of question that would be about attractions, we always need to mention 3 things and ask a question. But then maybe your domain also covers what are restaurant recommendations. And then you actually expect a different kind of behavior. And maybe here you want to ask a question first before giving the recommendations, and then things like that. So you can define different evaluation questions for different categories of your questions. Okay, and the way it would look like if you would code it yourself is literally you just write a prompt where you can say something like, okay, this was my evaluation question, and this is the response of an LLM. Please evaluate it against one another. And here you can experiment with this and improve your LLM judge until it matches your manual labels. Then there's another way to build a data set. You can use a reference. So now we have the question and then the reference output written by humans, so what you expect the model to return, and then the real output of the LLM, and then you are checking if they were similar. And the last thing, you can do pairwise comparison. So let's say you've written different prompts, 2 prompts, and you are now evaluating those 2 prompts against each other. You can run your test set against 2 models, and then you would ask which of those 2 outputs was better. And then, of course, you need to be very specific about what better is. When you work with LLM as a judge, you need to be mindful that it can get expensive if you are using third-party LLMs and you have a huge data set. It also comes with hallucination risks because in the end, it's still LLMs. Some things that you can do to improve your LLM as a prompt are same as when you are doing like regular prompt engineering, but for LLM as a judge specifically, it helps if you are using binary scores. So yes or no, polite or impolite. It's just easier for the model to predict. If you explain each of the score really well, if you are adding examples, using low temperature, using more capable models if you can, returning JSON also helps because then afterwards you can parse it. So response, score, explanation, and things like that. And you always need to evaluate your LLM as a judge. So it's like an endless cycle of evaluation. You have an LLM, then you have an LLM as a judge, and then you're evaluating it. But this is what we need to do. I think at some point it stops. So you evaluate your LLM as a judge manually, and this is where it stops. But it also takes few iterations for you to be happy with your LLM as a judge prompt. There are different LLM as a judge implementations. I already showed you that you can use your own prompt. There are also different implementations from libraries, and there is something called Eval. So let's go through a few of them. Evidently has their own library for LLM as a judge, where you can choose between binary and multi-class classification, and you can define your target category, non-target category, and uncertainty. So what do you do if neither could be predicted? And you can also include the explanation. And then there is something called Eval. Who knows what Eval is? Okay, not many. So there is a paper on that topic. Basically, Eval is a more structured LLM as a judge. It's an attempt to build something more robust. And the way it works is that you define a task instruction. For example, you need to read this text and evaluate if it is friendly. And then we are also defining evaluation criteria, like what friendly is. So friendly is when, I actually don't know what friendly is. Friendly is when you are using nice words and not offending anyone, let's say. And then we are using auto chain of thought to extract proper evaluation criteria from my task. So we split it into separate things. Separate criteria, and then those separate criteria are applied to your LLM output one by one. And then afterwards you get a score for each of those evaluation criteria, which is then combined to produce the final Eval score. And DeepEval open source library has their own implementation of this Eval, which works even a little bit differently. So instead of, you can still provide this evaluation criteria, and then they will use a COT chain of thought to split it into separate evaluation criteria, or you can define the evaluation steps yourself. And then you are skipping this LLM step and you get better output. And you can also define something called rubric. So you can define different scores for each of the things you want to measure. For example, measure the fluency of the actual output, and you say, for this I want the score from 0 to 3. And then for measuring the logical flow of the actual output, I want the score also from 0 to 3. And then this is also used to get combined into the final Eval score. Okay, so we now know about different metrics that are available. What can we evaluate? You can see LLM evaluations as two categories. So you can evaluate RAG, retrieval augmented generation. Who doesn't know what that is? Or maybe who knows? Okay, well, I'll quickly explain. So RAG is when you have a text, you have a user message, and you go to your documents and you try to find the relevant document to the user message, and you take this and you paste it into the prompt to ground your model and reduce hallucination. So you can do RAG eval, so evaluate this retrieval, and you can evaluate your generation. Let's start with examples for generation evals. Let's say you have reference output, so the one labeled by humans, and the LLM output. And then here you compare the similarity between them. So you can use similarity score, BERT score, Rouge Blue, or LLM as a judge that we just discussed. Then we can also compare user message with the LLM output. So user said, what is your pet policy? And the output was cats and dogs are allowed. And here you can measure something called answer relevance. So was the answer that was returned by LLM relevant to what the user asked? And there are different implementations for this metric as well, like LLM-based, cosine similarity-based, and others. Then you can also evaluate RAG. And here you can do a few things. So one, you can define the ground truth context. So which context you expect your RAG to return. And then you are also running your RAG, so you get the actually retrieved context, and then you can measure precision recall between those two. Or you can take your retrieved context and compare it with the LLM output and see if your LLM output was anyhow based on this RAG context. On the right side, there is this image from Amazon Ref Checker. So like just for you to understand how that might look like. If they overlap, then either they agree with each other, so entailment, or they contradict, or if there is something in the references in the RAG which is not in the response, then there are some missing facts. And then, I don't know, somehow when something is in the response but not in the references, Amazon labeled it as neutral, but I think that's actually called hallucination. But I think this image makes sense anyhow. Okay, then you can do hallucination check. So check if the retrieved context contradicts the LLM output, and this you can also do with LLM as a judge. You can write your own hallucination check actually. So just pasting all your data like user question, model response, and then defining what you want to predict. So is there a contradiction? Is there a missing fact? Is everything correct? Or you can do it a little bit more complicated and return a JSON with the type of overlap. So was it disjoint, equal, subset, superset, overlapping, and the final score contradiction, true or false. You can also use existing libraries. That's what we are using for our clients, the one from Eval. And you can also use the Eval hallucination check. This we already talked about. Okay, and then there is also something called RAGs. That's a collection of 4 different scores that compare with each other the LLM output, user input, and the RAG context. And here there are 4 different metrics: answer relevance, answer faithfulness, context precision, and context recall. And when all those 4 are combined together, then you get the RAG score. But you can also calculate all of them separately. And you can use the one from Eval, or there's also RAGs library available. Yeah, so there are plenty of metrics to choose from, and I can't tell you which one works best for your use case. You need to choose yourself. But yeah, there are a lot, so everyone should be evaluating. Okay, now a 3-stage LLM framework. It consists of 3 steps. The first step is the experiment step. This is when we define what good is, and we run experiments, both manual and automatic, and we do that on repeat until we feel like, okay, it's kind of good enough. And then we do testing before release, so we run regression tests, so we are sure that, okay, now we can safely release to production. Then, during the monitoring stage, so when your application is live and in real time, you can have guardrails, input guardrails and output guardrails, and we'll talk about all of that in more detail soon. Then you need to log your data, and you can set up real-time alerts. And during improve stage, so already post-production, when you have the logs, you will analyze the logs, you will debug what went wrong, and you will find in your logs what needs to be improved so that you can update your features, but also update your test set. So it's a continuous process, and after improve, you go to experiment, and then you keep going. Let's start with experiment. When we are doing experimentation, there are 2 eval questions. So first, how do I know if my new prompt is better than the old prompt? So we need some metric for that. And also, can I safely release to production? And this question you ask yourself every time you update the prompt and every time you update the underlying model. So during experimentation, we would want to catch any regressions before making the release. So running the regression test, we would want to track different metrics to compare experiments, and you can use metrics that we just discussed to help you with your experimentation phase. And the experimentation plan is that I personally always start with wipe checking, because it's just faster. So I first see, okay, was it better or not? Was it better or not? And then at some point when I think, okay, it was better, then I run it on my test case to get those automatic scores. And then afterward, I still always manually review to see if those automatic scores make sense. So for wipe checking, you can of course just run it in your Python console and then check, but you can also use playgrounds that offer version control of your prompt, so you can always see which prompt was there. This one is from Agenta tool, but there are other tools that allow you to do those experimentations, and I find it nice. For automatic scoring, there are things like unit tests, so you will write unit tests for your prompt, for rag, for functions separately, then integration tests when you test it together, and end-to-end testing, so when you maybe simulate your full conversation or the whole flow of your app, and you do the CI/CD as well. Like I said, I always still do manual reviews. Because we want to use automatic testing to scale our judgment, not to replace it. And for that, we really need to know what is good. And for that, we still need to be looking at it manually and use automatic testing as a help. Okay, now real-time guardrails. There are two types, input guardrails and output guardrails, and we'll go through them one by one. So input guardrails is when a user sends a message and then we have something that checks if it is safe or not safe. If it is safe, then we can send it to LLMs safely. Or if it is unsafe, then we somehow define what do we do in that case. Do we just say to the user, okay, we don't want to talk to you anymore, or we guide them somehow, so design decisions to be made. And this we do because we want to catch things early, and we also want to reduce LLM costs. So imagine if someone is doing a lot of jailbreaking and you will keep sending it to LLMs all the time just to find out that the output was bad, you'll waste a lot of money. So for topic guardrails, the ones about bias, toxicity, and things like that, I personally wouldn't add them in real time unless you're working in a really sensitive use case, because when you are working with those real-time guardrails, they add latency to your application, and some applications are latency sensitive. So instead, I would actually add them into your test set. So when you are doing the experiments, I would test that things like that don't happen. Unless, like I said, it's a really high sensitive domain that you're working on. For the output guardrails, we are now evaluating the model output. So user message, then you generate a response, then you check if the response was safe, and then you only show it to the user if it was safe. So here it's good to check if there was any PII leaks, hallucination, unsafe content, and things like that. And if it is unsafe or it didn't work, then you can decide also if you want to keep regenerating it or fall back and say to the user that you can't help. I would always do hallucination check and syntax check before displaying the response to the user. And I would regenerate once if it failed, and then I would fall back and say, okay, sorry, we can't help. And for topic guardrails, I think I already said. So for LLM guardrails, you can use the ones from your provider. So OpenAI has those 6 categories. Then AWS, actually this was 5. AWS has 6 things that you can predict, like hate and fairness, violence, copyright infringement, and things like that. You can also do DIY, so we already know what LLM judge is, so you define your own prompt and your own guidelines. And you can use deep eval, Eval as well. Or you can use Python libraries like LlamaGuard free. They have 14 different input and output moderation guardrails that you can use. And yeah, remember that moderation filters slow down the response speed, so only use them when needed. Okay, now we have real-time and production monitoring. You can't optimize what you don't track, so you do need to have logs. I every one of you already is logging things, but things that I would log: input, output, and context, a model that you are using, prompt version that you are using, and feedback from users. So you can then use this data in the analytics stage. And you can use those logs to analyze the failed cases and to improve your test set coverage. For the monitoring in real life, so when the application is already running, you can also escalate certain issues immediately. So if you notice that there are some, if you're building chatbot, no response loops or weird outputs, you can immediately send alerts to your team so that they go and fix the backend code immediately. Or you can also do a mechanism where in those cases users get help in any other way. So maybe your app says, okay, we'll transfer you to a human now because something weird is happening. And the last stage is post-production analytics. So here we want to answer the question, how do I know what do I need to improve next? And because we already have the logs, that should be fine. We can quantify the progress, we can track our KPIs and measure the success, and we can identify areas of improvement and improve our test case. And here I would monitor the same metrics that we would do during experimentation. I would monitor KPIs, hallucinations, custom criteria, and the feedback that the user gave to your application. There's a bonus. There are also all-in-one platforms, and a lot of them are open source. These are the open source ones that I found. So they have a different of those things that I already discussed, but then in a platform, and they also have the open source libraries. So the features that I would look for is like LLM playground, so I can do like version control and quickly iterate on my prompt, set LLM as a judge, human evaluation feature is also nice. There are actually plenty, and someone said this is a scary slide. I'm not going to read that for you, but there are different features that those platforms offer, and you can have a look. Yeah, just a reminder, I also put them together in this like open source tab in this LLM Eval library, so you can explore the ones that you like. And the final recap. So there are 3 stages: experiment, monitor, and improve. During experimentation, we define what's good, we run experiments, and then we do that several times, and then we always test before we release with regression tests. During monitor, we decide if we want to set the input to output guardrails. We always log the data, and sometimes we set real-time alerts. And during improve, we analyze our logs to discover what needs to be improved. So to wrap up, always write, oh, actually, I think I kind of forgot to mention it, but always write tests before the prompt, so test-driven development for the LLM as well. So we always start with the test, and then only afterwards we are doing the automatic scoring. Then define what's important for your specific use case, work with SMEs to define what is good, and build a realistic test set that's based on the real-life production logs. Define custom criteria, do regression test before you release, log everything in production, and keep improving. I think this is an ever improving process, and your test set will be evolving as your app is evolving. This is a QR code to my LinkedIn. I'm sharing there are things related to Gen AI, conversational AI, so if you want, you can stay in touch with me there. And I'm happy to answer your questions.